Just consider two kids trying to get a mango from a tree using a catapult. When you aim to hit the mango with an applied force on the catapult, it tends to change its position. After the force has been released, the stone hits the mango and the catapult regains its original position. This process is known as elasticity. On the other hand, when a force is applied to a paper clip, it bends down, so its size and shape gets changed, and does not regain its original size and shape. This process is known as plasticity. Consider an office scenario. Here the boss is really pissed off with the employee. The pressure created by the boss on the employee is the stress. Now the employee gets depressed here, which is called as strain. As a result of it, the employee does the work with perfection. This change in his attitude is deformation. The strain has three types. Let me explain this scenario in a mechanical workshop. Consider an iron pipe, which is about to get a change in its shape. The change in length here is linear strain. Simultaneously the volume also changes, which is known as volumetric strain. And the amount of force applied on the iron pipe will be the shearing strain. Similarly, the stress has three types. Consider the same scenario. The force applied along the length of the iron pipe is longitudinal stress. When you dive into a pool, your body is subjected to uniform pressure on all sides created by the water, called hydrostatic stress. When a watermelon is chopped with the help of a knife, an amount of stress is developed on the knife, and as a result, shear stress is developed on the watermelon. The force acting perpendicular to the object is known as shear stress. According to Hooke's law, the stress is directly proportional to the strain. For any kind of substance or material, there would be some factors which would affect their physical properties. If you take a t-shirt from your cupboard and shrink it with your hand, some strain is developed on the t-shirt. The amount of stress given will be the strain. As a result of applied stress and strain, the length of t-shirt gets changed. Due to the changes in length, t-shirt gets elongated. Usually, when t-shirts are exposed to higher or lower temperatures, it would affect its elasticity. Regarding impurities, let us consider gold. More the alloy you add, less the purity of gold will be. With subject to the nature of crystal, pure gold has more elasticity compared to the gold that contains alloys in it. Similarly, every material or substance will have the resistance to break at one point. But how it gets affected scientifically? By the brittleness and ductility of the material. Consider a chewing gum that is kept in different conditions, at room temperature as well as in a freezer. At room temperature, when you give an applied force to a substance, it will stretch, bend or deform before breaking. A substance that can be deformed before breaking is said to be ductile. Other examples of a ductile property are metals and plastics. Opposite of ductility is brittleness. When the substance is taken out from the freezer and tend to deform, it breaks without any deformation. Other examples include glass and ceramics. Each and every substance have different tensile strengths, and vary according to the different atmospheric conditions, such as temperature, pressure and so on. The following table enlists the strength of different substances or materials.